Have you ever wondered how massive ships weighing thousands of tons can float while a tiny pebble sinks straight to the bottom? Today, we're diving into the fascinating science behind why boats float. Let's start with a fun fact. The ancient Greek scientist Archimedes made this discovery while taking a bath. As the story goes, he was so excited about his discovery that he ran through the streets, shouting "Eureka!" The secret behind floating boats lies in something called buoyancy. Think of it this way. When you push an inflated beach ball underwater, it wants to pop right back up. That's because the water is pushing back against the ball. This same principle applies to boats, but there's a clever twist in their design. When a boat sits in water, it pushes aside or displaces an amount of water equal to its volume. Here's the magic. If the weight of the water displaced is greater than the weight of the boat floats. It's like a game of balance between the boat's weight and the water it pushes aside. But why can boats be so heavy and still float? It's all about shape and space. Boats are designed with hollow hulls, which means they take up a lot of space while keeping their weight relatively low. When you spread the weight of the boat across its large hull, it displaces enough water to create sufficient upward force to keep it afloat. Let's use a simple example. Imagine taking a ball of clay and dropping it in water. It sinks, right? But if you reshape that same clay into a bowl shape, it floats. The weight hasn't changed, but by changing its shape to displace more water, we've created buoyancy. Modern ships take this principle to the extreme. Cruise ships, for instance, are built with massive hollow spaces inside their hulls. These spaces allow them to displace an enormous amount of water while keeping the overall density of the ship less than that of water. It's like creating a giant bubble of air wrapped in a steel shell. But there's a limit to how much weight a boat can carry. This is called its displacement capacity. When a ship is loaded with too much cargo, it sinks lower in the water until it reaches its load line, a safety marker painted on the hull that shows the maximum safe loading point. This amazing principle of buoyancy doesn't just apply to boats. It's the same reason why you feel lighter in a swimming pool, how hot air balloons rise, and why icebergs float in the ocean. Nature's laws work consistently, whether we're talking about a rubber duck in your bathtub or a massive container ship crossing the ocean. So the next time you see a boat floating on water, remember, it's not magic, it's science. It's a perfect example of how understanding and working with nature's principles allows us to create amazing things. From simple canoes to massive aircraft carriers, they all float thanks to Archimedes' brilliant discovery of buoyancy.